Here we are with another graphing of an exponential function. This is an exponential function because x is in the power zone. So whenever x is in power, this is exponential. X is in the exponent zone. So it's exponential. Okay, so how do we graph it? Well, we know in general that exponential functions have, if you have an exponential function of the form y equals a times b to the x plus c, the number added or subtracted off to the right, that's the horizontal asymptote. So you have a horizontal asymptote at c, and then the function will rocket up to the right. Now, there's other exceptions. The function can go down to the right if certain things are happening, or the function can go like this, or the function can go like that, depending on how it might be flipped or turned with negative signs or fractions. And in fact, we have a negative sign and a fraction on this one, so we're expecting some turns and flips and things. All right, so let's get to it. So I'm giving you the general look, and now we'll do this specific example. So y equals negative 1/4 to the x plus 4. How do we do it? How do we go about graphing? Well, first off, observe the number added off to the right is missing, so it's 0, right? That's my c. It's missing. So if there's no number added or subtracted off to the right, put in a plus 0. Why plus 0? Well, because if you did like any other number, like plus 1 or plus 2 or something, that would change the problem, wouldn't it? We can't put in a plus 1 that was never there before. Adding 1 changes the problem, but adding 0 doesn't change anything. So it's like it was adding 0 all along. So what? Well, that means 0 is our horizontal asymptote. So we know, right, exponential functions always have a flattening side. So in general, exponential functions always flatten out on one side, rocket up or rocket down the other side. So, depending on which way, as we've seen, as I showed you in the pictures above. So exponential functions, they always, let me write it for you, they always rocket on one side, up or down, and flatten on the other side. That's what they always do. They rocket on one side and flatten on the other. So the horizontal asymptote is where they flatten out. It's the number added off to the right, which is 0 in this case. Okay, so let's make our table now. So XY table, I'm just going to plug in. I always just start with 0 because it's often nice, not always. So negative 1/4 to the 0 plus 4. Just plugged in 0 there for x. What is that? That is negative 1/4 to the 4. Now, 1/4 to the 4, if you use your calculator, I'll just change to decimals at this point. I'm going to go 0.25 to the 4th power. I'm getting negative 0.0039, so I'll just say 4. Negative 0.004. In other words, it's over 0, barely negative. So it's a dot, but it's not going to be one that our graphing tool can actually locate. So we need to do something else. How about if we do 1? So we'll get y equals negative 1/4 to the 1 plus 4. So again, use your calculator. 0.25 to the 5th. And now, oh yeah, let me tell you what I'm getting. When I do my calculator, I get negative 9.765, blah, 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 blah. E minus 4. I don't know if your calculator shows it that way. Do you know what that means when it says E minus 4? That means exponent minus 4. That means times 10 to the minus 4 power, which means take this decimal and go minus 4, 4 places back. 1, and you're to the edge. 2, 3, 4, those bring in zeros. In other words, this is negative 0.0009765. Did you track with all that? So when your calculator says e to the minus 4, that means take that decimal and go 4 to the left. If it said e to the plus 4, we'd go 4 decimal places to the right. It's scientific notation. It's saying the exponent on a 10 is negative 4, which means move the decimal 4 places to the left. Minus is to the left. So I go 1 jump to the left and I'm to the edge. The other 3 jumps going beyond the edge, bring in zeros. So it's that number. In other words, it's super small again. So it's even smaller, right? I mean, it's, if you round it, it's negative 0.001, isn't it? You round that 9, so it's negative 0.001 in that third spot. I just rounded to the third spot there. So anyway, my point is, if you go over 1, it's even closer. So you can tell it's kind of going up like that. It's getting closer and closer to 0. That's even closer to 0. We want to go the other way, clearly. We're getting some crazy values. Let's go the other way. Let's go to the add page for us to have room here. Let's try going to negative 2. See what we get there. Wait a minute, where did I come up with negative 2? Let's do negative 1. So I went 0, got this dot, went 1. Looks like going to the right, it's just flattening like this. Do you see that? Because it's getting closer and closer to 0. So let's go the other way. Let's go negative 1. So if I do negative 1, I'm going to get y equals negative 1/4 to the negative 1 plus 4, which is negative 1/4 to the third. Hit the buttons on your calculator. I'm getting negative 0.02. I'm going to round it. Negative 0.02. Well, it's still not. Yeah, at this point, I'm getting tired of the decimals. Can you see what we could plug in up here to make it a little cleaner? Negative 4. Do you see that? If I plug in negative 4, I'm going to get y equals negative 1/4 to the negative 4 plus 4. And so that's negative 1/4 to the 0. And anything to the 0 power, do you remember, is 1. So that's negative 1. It's got a negative in front, and this guy becomes 1. Anything to the 0 power is 1. You can try it on your calculator. So back 4 down 1. There's a point we can sink our teeth into. Back 4 down 1. Do you see how this graph is going this way like this? Let's get another one. How about if we go to like negative 5? Then we're going to get y equals negative 1/4 to the negative 5 plus 4. Now what's that? That's negative 1. Now, the negative's in the front. What does a negative power do to something? Do you know that? So you need to know two rules really clearly. Anything to the 0 power is 1. Anything to a negative power flips it, and then the power becomes positive. You need to know that rule really well in this chapter. Negative powers do not produce negative answers. They produce fractions. They flip it. So this guy's going to flip and become 4/1. So in other words, it's just negative 4. Because this negative sign was already there. That's the reason it's negative. And then this guy just flipped it. So it's negative 4. So negative 5 minus 4. So that's right here. There we go. So negative 5 minus 4. This is the other point. Negative 4, negative 1. There's the two easiest points to graph. I didn't make that very smooth, but you get the idea. There's what the graph is doing. See how it's flattening on this side, and it's rocketing down on that side. Exponential graphs always flatten on one side, rocket on the other. The main way I found points, all these points were true, but they were hard to graph. So I just tried different numbers until I got clean whole number values. The main thing to remember is negative powers flip things. That negative 1 flipped it. And 0 power is 1. Make sure you know those two things. And so there's the graph. We just have to click this dot, and the graph tool will make that graph for us. There we go.